Hello, lovely year nines. So today what we're looking at is inequalities. We have been looking at equations, but today we're looking at inequalities. You might be thinking, well, what is an inequality? You've probably heard of the term inequality, and I've got a good example here. You've got some characters from our hit TV show DuckTales, which was a hit back in the day, probably still is now. And on the left here, we've got Huey, Dewey, and Louie with good old Scrooge McDuck. They're in his big vault, which has lots of money in it. And then got Donald Duck here on the right, and he's emptying his pockets. He's got none, and we might be thinking about what they have or how much money that they have. And we're thinking, do they have an equal amount of money? And we're thinking, well, no, they're unequal. They are not equal to one another with the amount of money that they've got. And so rather than saying that they're not equal to, we could say, well, that Scrooge McDuck here has more money than Donald Duck on the right here. That's essentially all inequalities is about. We're dealing with scenarios things that just aren't equal to one another, but things that are more than or less than one another. Let's actually take a look at the DuckTales theme song. It's a pretty good theme song. Let's get this up and going here. Oh. Life is like a hurricane in Duckburg. Race cars, lasers, aeroplanes. It's great song. So there's Scrooge McDuck, Huey, Dewey, and Louie. Woo. How fun would that be? Big vault full of money. Anyway, we'll stop it there. Anyway, you watch it in your own time. Great TV show. Get onto it. All right. Here we go. So now we're talking about inequality. So we're dealing with things that are either more than or less than. And we've also got things can also be more than or equal to a certain amount as well. So we've got our two symbols here that you can see. So that means less than or equal to. That one there means greater than or equal to. And we can use these to identify a series of points rather than just a singular value. So basically looking at a collection of numbers. So in this diagram here, we can see that we're starting at 2 and we're going every value less than that there. You'll notice that the 2 has a little circle around it that isn't shaded in. And so if it's not shaded in, then it is just less than, it's not equal to. In the second example here, our dot is shaded in, so it includes that. So here we're going from -1 and greater than, so that's greater than or equal to that particular value there, okay? So let's do some examples here. Let's graph each of these, the sets on the number line. So we're starting at -2, and we want everything less than that. So I'm going to draw myself a circle. I'm going to fill it in, and then I'm doing an arrow to the left there. Cool. For the next one, we want x is greater than 3. So we're at 3, but it's not equal to. So I'm just doing a circle and not filling it in, and greater than. So I'm going to the right. And for the next one, greater than or equal to 3.5. So basically I'm at 3.5. I'm filling it in because it's equal to as well. And I'm going to the right because it's greater than there as well. Okay, simple as that. Use set notation to describe each interval. So back up here, this is the correct notation for talking about sets. So basically we use these squiggly brackets. So I want to do the set of x. And so that is all my the values of x now, and I'm putting on some conditions. So set of x, and then do the semicolon there with the conditions that x must be greater than, because it's going to the right, or equal to, because the circle's filled in, greater than or equal to minus a half, and then I close the squiggly bracket. So that is the set of values x, where x is greater than or equal to a half. So next one here, I want the set of values of x. So basically, because we're basically just dealing with the x-axis here, that x is less than, and it's not filled in, so it's not equal to either, 1.5. So I'm just going to put here 1.5, and I close my bracket. So that's the set of values there. So there we go.